Hi guys, my name is Dolu, and today I'm talking to you about conditional probabilities and Bayes' theorem. A quick introduction. My name is Dolu Shola, and I currently work as a data scientist in the security industry. And I started picking up data science about 5 years ago while I was still in university. However, most of the things I've learned and the bulk of my learning has come from doing exactly what you're doing right now, taking online courses and building great projects. So welcome and congratulations on taking this step. So a brief history of Bayes' theorem. Bayes' theorem was originally derived from a paper from Thomas Bayes a very long time ago in the 1700s, but still super important today because the principles of Bayes' theorem are still used in powerful machine learning algorithms, statistical modeling, such as LDA, naive Bayes, and even specialized neural networks. So let's get to it. So Bayes' theorem is simply a way for us to make good estimations of the unknown using the things that we do know. So it may seem a little bit complex, but it's actually really intuitive and it's very similar to the way we naturally think. But first, we should review conditional probabilities. And so I assume that you do understand a little bit about conditional probabilities, but I've made up this motivating example. So imagine kids play football in a field close to you, or soccer as you may call it. In the past 10 weeks, you see that kids play every weekend. Kids cannot play on weekdays at all. So we can formalize this statement by saying that the probability of kids playing, given it's the weekend, is 9/10. And the probability of kids playing, given it's a weekday, is 0, because they are simply not allowed to play on the weekend. Maybe like it is closed, the field is closed on weekdays or they have school. And so imagine now that you've been sent into the future and you're trying to figure out what day of the week it is. And so the best way for you to make a very good informed guess is to check whether kids are playing. If kids are playing, you can assume it is a weekend since kids are not allowed to play on the weekdays at all. So can you estimate the probability of kids playing on a weekday, of it being a weekday if kids are playing? So that probability will be 0 or near 0 because kids are not allowed to play on weekdays at all. And so can you estimate the probability of kids playing on a weekend or the probability of it being a weekend if kids are playing? So that probability is 1. And so if you guess 1, you're right. And so this is because kids are only allowed to play on weekends. And so this was a pretty straightforward example. But this is just how Bayes' theorem works. And it's also the way we naturally think. And I hope I've been able to convince you of that. Let's imagine kids play every day and we've been sent back to the future again to estimate what day it is given kids are playing. You can, but we just have to use what we know to estimate what we do not know. So let's look at what we know. So we know the probability of kids playing given it is a weekday. And so that's because we've been passing the field every day and we've been recording it. You can use a decision tree here or a probability tree, however you call it. Remember how this works. You multiply this probability in the first node by the probability of the second node to get an estimate. However, that's when we do the multiplication and not real probabilities, even though they look like. The reason is because real probabilities should add up to 1, and they don't add up to 1. But there's a simple way to make them add to 1. And here we just neglect kids not playing because we're only concerned with kids playing. What we do is we take each of these estimates that divide them by the sum of these 2 estimates. So we take these 2 estimates, we sum them together, and then we take each of those estimates and we divide them by that sum. What I found out is that this sum is the probability of kids playing in general. Because if you think about it, kids can either be playing on the weekend and it is a weekend. That's where the time comes from, the and the kids can be playing on a weekday and it is a weekday. That's where this time comes from. And so the or, so it's either they play on a weekend or they play on a weekday. And that's where the plus comes from. So if you remember the rules of probability, you'll be able to see that or how it is. And then so we can rewrite our formula rewrite this sum as the probability of kids playing in general. We can now find the probability of it being a weekend while kids are playing with these simple formulas here. And so that's how we derive the Bayes' theorem. So thank you very much for your time. It has been very great explaining.